Okay, now for what we have in the fourth problem, we're looking at the integral of the natural logarithm of 5x over x squared times dx. Okay, and then we have setting up our terms. We have u is equal to the natural logarithm of 5x, and we can set dv equal to the reciprocal of x squared dx. Now, u is going to go to du, and so far as what we're going to have in dx, okay, again, we're looking at taking the derivative of the natural logarithm of 5x. Okay, and so along the lines of the algorithm pertaining to the derivative of the natural logarithm of x, okay, we are going to have the reciprocal of 5x. And again, do not forget, okay, that we were looking at having to take the derivative of 5x, which in this case is going to go to 5. So you have 1 over 5x times 5. Okay, that is going to be at 1 over x. Okay, so du is going to end up at 1 over x dx. And so far as what we have for the antiderivative of 1 over x squared dx, okay, we're going to have, again, just consider for the antiderivative of 1 over x squared dx, okay, you're looking at the integral of x to the negative 2 dx. Okay, and that is going to be x to the negative 2 plus 1 over negative 2 plus 1 followed by the constant. So you have x to the negative 1 over negative 1, or by then you're going to have negative 1 over x. Okay, so your antiderivative term is going to rest at negative 1 over x. Now, in setting up what we have, okay, we have for u times v, okay, we have negative 1 over x times the natural logarithm of 5x. Okay, we have minus the integral of v times du. Okay, so we have minus the integral v times du, so we're looking at the subtraction of negative 1 over x squared dx, and subtraction of a negative is going to be the addition of the positive. And so for what we're going to have with history repeating itself, we're going to have the antiderivative of 1 over x squared dx, which again will go to negative 1 over x. And so for the final answer, in the case problem number 4, okay, we have again the negative of 1 over x times the natural logarithm of 5x, and then we have minus 1 over x followed by the constants. In the case of what we have in the fifth problem, okay, we're now looking at the integral of x times the square root of x minus 76 dx. And so we have another integration by parts problem. Okay, there's no square term inside the radical that can be used to cancel out x once we cross over to the derivative stage. Okay, so we have with this setup here, we set u equal to x, whereupon du is going to be equal to dx. And as for dv, okay, we had the square root of x minus 76 dx, and the antiderivative, okay, this can go to 2/3 of the quantity of x minus 76 to the 3/2. And so in carrying out what we have for u times v, okay, we have 2/3 of x times quantity of x minus 76 to the 3/2. Then we have minus the integral of v times du, and we can drag the 2/3 on the outside of the integral. So we have minus 2/3 of the integral of x minus 76 to the 3/2 dx. And as we look at the follow through with the second integration, here we're looking at negative 2/3 and the antiderivative of x minus 76 to the 3/2. Okay, this will be 2/5 of x minus 76 to the 5/2. Now we can add in the constants, and so for the final results in this one, okay, we have 2/3 of x times x minus 76 to the 3/2 minus 4/15 of x minus 76 to the 5/2, followed by the constants. Now, in continuing with what we have for the integration by parts, okay, we have in this next problem, okay, there will be what is regarded as repeating integration by parts. And in the case of number 6, we're now looking at the integral of x squared times the cosine of x dx. Okay, so getting this to show up. Okay, again, we can set u equal to x squared and dv equal to the cosine of x dx. Now, had we had the x and the x squared in different positions, namely x for the variable coefficient, x squared for the angle, we could have applied just regular substitution, but in looking at how the factors of x are placed, okay, we need more than just mere substitution. And so, going back to the integration by parts, okay, we have in this range we had that u is equal to x squared, from which we have du is equal to 2x dx, and as for dv equal to the cosine of x dx, okay, we had that v is equal to the sine of x. And thus, for what we have in looking at u times v, okay, we have x squared times the sine of x, and then we have minus the integral of v times du, and so we'll be looking at subtracting the integral of 2 times x times the sine of x dx. So we have another round of integration by parts to be performed, and so for this one we have that u is equal to 2x and dv is equal to the sine of x dx. And we have du is equal to 2dx, and again the antiderivative of the sine of x dx, we have the negative of the cosine of x, and we're going to be distributing the negative sign from the prior step. And so for what we have at this juncture, okay, we have x squared times the sine of x minus, okay, then we have quantifying, have u times v, so you have negative 2x times the cosine of x, then we have minus, okay, the integral of v du, so that's going to be a negative 2 times the integral of the cosine of x dx. Okay, now within the grouping symbols, again, we have a positive integral term. However, as we distribute the negative from the prior step, okay, what was negative inside the brackets will be positive, and what was positive will be negative. And so we have, in setting up our next to last step, okay, we have again x squared times the sine of x plus 2x times the cosine of x, and we have minus 2 times the integral of the cosine of x dx. And so we have, for the final answer in this one, we have x squared times the sine of x plus 2x times the cosine of x. Then we have, finally have minus 2 times the sine of x, followed by the constant. Now, in the case of what we have for item number 7, okay, a little bit of a trick one here, not too bad, however. Okay, we have in this problem, okay, we are now looking at the integral of 5 times the arctangent of x dx, and for this one, okay, we can set u equal to 5 times the arctangent of x, and then we can set dv equal to dx, and with the differentials, okay, we have arctangent of x will be the reciprocal of 1 plus x squared, and 5 times this. We have for du, this will be 5 over 1 plus x squared dx, and the antiderivative of dx is going to go to x. And so for what we have here, with the integration by part, u times v, we have 5x times the arctangent of x, and then we have minus the integral of v du. So we have 5 times x all over 1 plus x squared dx, and as we look at just momentarily stepping to the side, just a little reminder, okay, for the remaining antiderivative, again we have the integral of 5x over 1 plus x squared dx, and there's a 1 degree difference between the denominator and the numerator, and so if we were to apply substitution for this second integral, okay, what's going to happen is that for the derivative of the denominator, okay, this will be at 2x dx, whereupon du over 2x is equal to dx, and as we look at applying substitution, okay, we're looking at the integral of 5x over u, and dx we have it du over 2x. Guess what? We have factors of x will cancel out, and we will have 5 halves of the integral of the reciprocal of u du, and by then we have 5 halves of the natural logarithm of u plus c, and with the back substitution, our next antiderivative, we're going to have at 5 halves times the natural logarithm of 1 plus x squared. And so putting this back in, it's going to follow that for the final answer for the integral of 5 times the arctangent of x dx. Okay, we're going to have 5x times the arctangent of x minus 5 halves times the natural logarithm of 1 plus x squared, followed by the constant.